Hello class, so here is the first test for convergence or divergence. As you can tell, this one is for divergence. Alright, so what it says is that if the limit as n approaches a of a sub n does not exist, or the limit does not equal 0, then the sum is going to diverge. Alright, so let's think about why that makes sense. So the sum basically just tells you that we're adding a whole bunch of a sub n's infinitely, right? So in order for it to converge, things have to obviously get smaller, otherwise you're just going to keep adding bigger and bigger things, and you're never going to get closer and closer to anything specific. So that means if the limit as n approaches infinity of a sub n is not 0, we can conclude that the terms are not getting smaller, or at least not smaller enough as quickly as it needs to be. Okay, so let's think about this though. Does that mean that if the thing if a sub n approaches 0, then the sum converges? We can test it with this, and I already have the numbers here so that we don't spend time filling this in. But basically, if you want to pause the video and see if you get these numbers, cool. But anyway, as we can see, as we let n approach infinity for this, so looking at the sums, they don't converge. This thing just gets bigger and bigger and bigger. So yes, the limit converges, or the sequence converges, but the sum does not. So this is divergent. And actually, this is something called the harmonic series. It diverges, so just know that. That'll come a lot in handy later on as we go through certain things with series. Alright, so what it tells us then is that if a sub n diverges, then the whole sum itself is going to diverge. So there's also another thing in logic called the contrapositive. So that just means you flip an if-then statement and then negate both parts. In other words, you take this, move it over there, negate it. What this is saying is the thing diverges. Then you take this part, take it over there, negate it. So basically what it's saying then is that if the sum converges, then that means a sub n has to converge. Well, what does that mean? That means that a sub n converging is only a requirement in order to qualify something to converge. But that does not mean that the sum is going to converge, as we just saw with the harmonic series up there. Alright, so when do you use this thing? You always use it. So you know how you always use direct substitution for a limit just to make sure, does this thing exist with direct substitution? Because that's obviously the easiest thing to do, right? Same thing here. You always want to just check to see, is this thing gonna diverge? So you don't try a whole bunch of different tests and see, oh, this is not conclusive, this is not conclusive. And then realize later on, oh, the thing actually doesn't diverge. So, yeah. Always just use it just in case. It could make your life a lot easier. Alright, so let's practice with this and see, is this thing going to diverge or might it converge? So the a sub n here is just that thing inside. It is the summand. Is this going to converge? Let's see. Or is this going to diverge? So let n approach infinity. So you're essentially going to get 0 minus 0. Or are you? So let's check. Let's combine the denominators. Or, I mean, the fractions. By getting a common denominator. So we get this. Whoops, forgot to write limit. Always write limit. Until you don't have to. Alright, so if we just take this limit, this we can actually deal with then. This is going to definitely approach 0. So maybe converges. Can't tell just from this, but maybe it converges. Alright, let's try this thing. So let's see, limit as n approaches infinity of ln of n minus 1 minus ln of n let's see, how can we work with that? So for logs, remember, same base, so you can combine them. And the subtraction tells you that we're going to divide. All right, so as n approaches infinity, this is going to approach ln of 1. In other words, 0. So this might converge. Again, we don't know if it converges or not. All right, so actually let's just look at one that obviously will diverge. I didn't plan for that, and you'll probably be able to see pretty obviously just by looking at it. How about this? Well, the limit as n approaches infinity of n equals infinity, therefore the sum diverges for sure. All right, so that's the end of this. Always test for divergence just in case. And yeah, because it might make life easier. All right, hopefully this was helpful, and see you guys in the next video.